Well, hello and welcome to Science Never Stops. I'm your host, Joseph Vick with the U.S. Space and Rocket Center, here today with NASA Marshall Space Flight Center guest, solar science astrophysicist Mitzi Adams. Welcome, Mitzi, to Science Never Stops.
Thank you. Good afternoon.
So, have a few questions here. If you could answer these and let our viewers know what it's like to do what you do. So could you please explain to our viewers about your field of study and tell us about some current NASA projects you're working on?
Okay, well, my job title is actually astrophysicist. And what that means is an astrophysicist would study things in the universe and the physical processes that go on and that cause them to happen, like supernovae or gamma ray bursts. But my specialty is solar science, so I specialize in understanding the sun. And specifically, I'm really interested in understanding how flares work, how coronal mass ejections work. And so I've been studying smaller events called jets that happen much more frequently than the larger coronal mass ejections. And the reason that I study those is because they happen more frequently, and that gives us better statistics. And we think that the things that cause them to happen are very similar than those that cause the coronal mass ejections to happen. So that's one of the things that I've been studying most recently. I also have studied sunspot magnetic fields. And of course, it's those magnetic fields that go into the atmosphere and affect the higher levels and cause these things to happen in the first place.
You mentioned that you study and focus on coronal mass ejections and jets, but you made mention that they're common occurrence. What would be a common occurrence? How common are they?
Well, coronal mass ejections don't happen all that frequently, and especially now that we're in sunspot minimum, we aren't seeing many sunspots, let alone flares or coronal mass ejections. But the little jets can happen even in sunspot minimum, and they're often associated with X-ray bright points, and they look exactly like what it sounds like. We can observe the sun in the light of X-rays with special observatories that are above Earth's atmosphere. And then we can see these bright points in the X-ray data. And then often those bright points will explode. And the bright points themselves are like little loops. If you can imagine a slinky, that's kind of what the loops are, and inside the slinky is gas that is confined by that magnetic field. And then something happens, the slinky gets twisted up, and energy is suddenly released, and then you'll have this jetting of material that you can see in the X-ray data.
A very hot slinky at that.
You know, actually, I didn't really answer your question, how frequent are these? And they are very frequent every day.
Oh, every day, okay.
You might see some 3 or 4 times a day. You might see them more often than that.
Well, you're very passionate about your subject from your description. Could you tell us about your educational background and how finding out how astrophysicist has made you become who you are today, or obtaining your current NASA position?
That's an interesting question. I've always been interested in science, and when I was younger, let's say before high school, I wanted to be an astronaut. I watched Star Trek, the original series, and my dream job was to be Spock's assistant.
Oh.
But here she comes. Mufuna.
Welcome.
But I had a decision to make. I really like geology. I like volcanoes and earthquakes and those kinds of studies and planetary science in general. But I felt that if I became an astronomer, that would help me, that would put me in a better position to possibly becoming an astronaut. And so I chose astronomy, and I started studying physics, and I earned a bachelor's degree in physics. And then in 1988, I moved to Huntsville because I was offered a graduate research assistantship at the University of Alabama in Huntsville. And along with that, I was offered a NASA internship or a co-op position. So that essentially assured me of working for NASA once I earned my degree. And so I have a master's in physics with a minor in math. And I started working for NASA essentially in 1988. That was my first work period, was in March of 1988.
That's a great combo. Now, growing up, you mentioned you took various physics courses, math courses, but growing up, was there a certain class, extracurricular activity, or a mentor, or overall experience that helped shape your career path or who you are today?
There were a couple of things. Interestingly, I had two favorite teachers, Carol McChesney and Ruth Wells, and they were both my Latin teachers. And they were extremely good teachers, and they really pushed the idea of learning, of lifetime learning. And they had a great influence on me. But also, I was an observatory assistant and a planetarium assistant at Fernbank Science Center in Atlanta when I was in high school.
That's a great museum. I grew up in Georgia, so I know Fern quite well.
At the time, it was the largest planetarium in the Southeast, and the third largest in the country. The size of the planetarium is the same as the planetarium at Smithsonian. They had a just excellent teaching program, a seismometer, a meteorology station, and the goal of the people who put the Science Center together was to have research scientists with masters or PhDs actually teach high school and elementary school. And as it was initially set up, this program allowed them also time to do their research. So they continued to be research scientists as well as teaching students. And I was lucky enough to be one of those that were allowed to use the planetarium and the observatory.
So, do you happen to have any special abilities, talents, or hobbies that might surprise people?
Well, other than the fact that I read Latin, still, I can also tap dance and I do ballet.
A tap dancing astrophysicist. That's pretty cool. So we will go on with Star Trek or Star Wars?
Both.
Why both? Why both?
They both have a place. Star Wars is a little bit more fantasy oriented, but it still has a place in science fiction as inspiring people. And Star Trek is more based on science than Star Wars, but they both have the ability to inspire.
I would agree with that 100%. And with that, is there anything else you'd like to add or say to our viewers?
No, I don't think so. I other than this is a very difficult time we're going through now with this virus. And I am honored to be given the opportunity to speak to people while we are quarantined, essentially. And I wish good health and live long and prosper.
Well, thank you again, Mitzi, for joining us today. And for all our viewers, remember, science never stops.